Okay, we're looking now at question 13. Given that n can be any integer such that it's greater than 1, I'll do this colour here, prove that n squared minus n is never an odd number. That's the proof question, and you get many questions like that, and what you need to do is set things up. Once you set it up, it actually is quite straightforward, but a lot of people do struggle with this. Right, let's assume a number. Let's assume it is n. So if n is odd, if it's odd, then you can write any odd number in the sense that you can write it as 2m plus 1. As an example, 7 can be 2 times 3 plus 1. So any odd number can be written as 2 times the number, that makes it even, then add 1 or take away 1, and that makes it odd. Doubling it always makes it even. And that's, in here lies your answer. So algebraically, I can write it like that. So now I'm going to do n squared minus n, but in this form here. Watch. I hope this makes sense. So I square that, and then I'm going to take away an n. And that's what it says there. Now, FOIL on this one, or the box. Most people like FOIL. I'm not a fan of FOIL, but I will go with the flow. So here we go, 2m plus 1. And at this point, guys, you are getting into the 7s, 6s and 7s and that lot. So this is bonus point. So don't forget, multiplication arm, first one, 2m times 2m is 4m squared, remember. Inner one, 1 times 2m. So that was outer one now. I didn't even get it wrong. I don't like it. 2m times 1, 2m. And then lastly, 1 times 1, and it's a plus times a plus. So with all of that, I end up getting 4m squared plus 4m plus 1. And then I'm going to minus 2m, I'm going to multiply this out, and minus the 1. And look what you get. You end up with 4m squared, 4m, take away 2m is 2m, and the 1's cancel out. And remember, what we said right at the top here is any number that you can multiply by 2 must be even. And we said, well, if it was odd, let's see what happens here. Well, I could take a factor of 2 out here, and there I go. And that makes it odd, okay? Because factor of 2 must be even. And that's a really quite interesting question in that one. Okay, so it's really nice. Now we get to question 14. Now 14 again is a really nice question. And for this one, you need to remember a few basic things, and that's what you've got to try to hold on to. So first of all, you need to remember some of the things like what is tan 30, what is sine 60. And there are lots of ways of remembering it, but if you're like me and you've got terrible memory, I'm going to do it this way. Imagine you've got an equilateral triangle like that. Cut that in half, so that is 60, that's 30. And therefore this length here is now 1. So that length is 1. And Pythagoras will say that this is root 3. Because it's 4 squared minus 1 squared, which is 3. Or, sorry, 2 squared, 2 squared minus 1 squared, which is 3, square root of 3. Now with that, I can go find these two, because I know that tan 30, tan, there's my tan, don't forget SOHCAHTOA, is my opposite over my adjacent. So my opposite over my adjacent, if I'm looking at tan 30, is going to be opposite over adjacent. And then I'm going to look at my sine 60. So here's my sine. This time my opposite is root 3, and my hypotenuse is 2. So now what I'm going to do, now I've got that, I can multiply them together. And lo and behold, these cancel out, and I'm left with a half. Hope that makes sense to you. Let's jump to question 15. I know time is not on us, but let's see what we can do here. Okay, I'll let you read through it. You can pause this, but I'm going to go straight into it just to help you. So I want the total volume. So the cone, they give me everything here, so I just have to fill this in. A third pi r, in this case, is 3. So times 3 squared times height 10. Add to that the volume of that one, but it's a semi hemisphere, so it's half this. I'm going to write it like this and then tidy that up in a second. And again, the radius. So now what I'm going to do is I'm going to do some tidying up. That's 9 divided by 3 is 3. So all of this ends up being 30 pi plus this. I can cancel down 2 over 3. 3 cubed is 3 times 3 times 3, which is 27. 27 divided by 3 is 9. So 9 times 2 is 18. I've gone quite quick, but hopefully you can see that adding that together is 48 pi. And they want, what is the value of k? So it's 48. Hope that makes sense now.